Okay, students, today's topic is branch operations. As we discussed previously, 8085 microprocessor performs various operations such as arithmetic operations, data transfer operations, logical operations, branch operations, and so on. So, this time we will be discussing about branch operations. Basically, microprocessor is a sequential machine, which means it executes its instruction in a sequential manner. As it executes machine codes from one memory location to the next in sequential manner. But branch instructions or branch operations allow the microprocessor to change the sequence of the program. Branch operations basically alters the sequence of operations because it executes normally from one memory location to the next memory location, but with the help of branch operations we can alter the sequence of instruction execution, and this sequence modification can be done either unconditionally or under certain test conditions. This alteration can be unconditional or a conditional. So branch instructions basically are classified in three categories. One, jump instructions. Second, call and return instructions. And third one is restart instructions. All these type of instructions allow the microprocessor to alter its program execution sequence. So let's start with jump instructions. Jump basically allow a microprocessor to jump from one memory locations to another different memory location which is not sequential. So jump can be unconditional jump or conditional jump. In unconditional jump, JMP instruction will be used in 8085 microprocessor, and this JMP instruction enables the programmer to set up a continuous loop. Continuous loop once it is used in continuous loop because in continuous loop no condition is tested. So if jump is transferring to some loop, then it will continuously to jump that location without satisfying some condition, because this is unconditional jump. So this kind of jump can be used to make a continuous loop. It can be one example of that. So second is conditional jump. As we have already discussed in 8085 microprocessor, 8085 microprocessor provides 5 flags which shows the status of result. One is carry flag, zero flag, another sign flag, parity flag, auxiliary carry flag. So jump is defined for JC instruction. If this instruction is used and after this a 16-bit address is specified next to this instruction, then this instruction will jump if carry set is set or 1. carry flag is set or 1. JNC instruction will jump if carry flag is not set. It means carry flag has value 0. Jump Z jumps if 0 flag is set. Same J and Z jumps if 0 flag is not set. JM for jump if sign flag is set. Sign flag is set, it means sign flag has value 1 and MSV1 will represent a negative number. So whenever the sign flag has value 1, it shows the result is negative. JP jumps if sign flag is not set. It means the sign flag has 0 value, which denotes positive number. JPE, this instruction is to jump if parity flag is set. Parity flag has value 1, it shows the even parity. Even parity, it means what? The number of ones in result is even. JPO, this instruction jumps if parity flag is not set. It means parity flag has 0 value, that denotes the number of ones in result is odd. Same with next we will discuss call and return instruction. We have discussed jump instruction. Now we will discuss call and return instruction. Both the type of instruction allow the microprocessor to change its program, the sequence of program execution. So 8085 supports conditional call and conditional RET. RET for return instruction. Conditional calls, same with the as we have discussed jump, the flag values will be checked. So CC instruction calls the subroutine. This instruction will call the routine which is specified by the address next to CC. So CC and then 16-bit address will be specified, and this instruction will call the subroutine if carry flag is set. CNC call the subroutine if carry flag is not set. CZ will test the 0 flag. C and Z will test the 0 flag for reset or not set. CM calls the subroutine if sign flag is set. It means the negative number, the result is negative. And CP call the subroutine if the result is positive. The sign flag has 0 value. Conditional return. So RC return condition, call condition is used to call the subroutine whenever the microprocessor executed that subroutine. After finishing that subroutine, the microprocessor will return to that location where it left the execution previously. So RC returns from subroutine if carry flag is set. RNC returns from the subroutine if carry flag is not set. RZ returns subroutine if 0 flag is set. RNZ not 0 flag. RM returns subroutine if sign flag is set. It means for negative number. RP returns subroutine if sign flag is not set. It means positive number. RPE returns subroutines if parity flag is set. RPO returns subroutines if parity flag is not set. So we have discussed jump instructions, call and return instructions. Now we are going to discuss about restart instructions. These instructions are similar to call instructions. Call instruction basically call the subroutine, but RST instructions normally used with the interrupt subroutines. So RST instructions are 1 byte call instruction that transfer the program execution to a specific location on page 00H. As we have discussed in 8085 microprocessor interrupt topic, the 8085 microprocessor has 8 type of interrupts: RST0, RST1, RST2, RST3, RST4, RST5, RST6 and RST7. And for these interrupt service routine is written on some specific address respective interrupt. So RST commands will transfer the program execution to these specific location. So here, when RST instruction is executed, 8085 store the content of program counter on the top of the stack and transfer the program to restart location, as we have discussed in interrupt processing. Whenever an interrupt occurs, processor holds its task, whatever it is executing, and save all the content and program counter value into onto the top of the stack and transfer to the location where interrupt service routine is written. So here the individual service routine location you will find as for RST0, the ISR will be on 0000H location. So RST command will also be used to transfer the control of microprocessor to different memory location specified with the specific RSTN. So these instructions are generally used in conjunction with interrupt process. So we have discussed branch operation. It means the processor executes one memory location to the next memory location in sequential manner, but whenever we have to change the program execution sequence, we can use branch operations. And branch operations can be implemented by some instructions such as jump instructions, call and return instruction, and restart instructions. So I think we have done with this topic. Thank you.